What I basically want you to do as a part of your assignment for this week is to basically attach. So last week what we did was we basically made a robot move using VREP. We controlled it using a Python script. But this time I want you to take it a little bit step further, and I want you to actually have like introduce your eyes to the robot. So you basically want to make a robot move until it sees an obstacle and then it stops. So I just set a random threshold of 0.5 meters, and I'll basically explain how to do that. And you can basically replicate that process, and you can add your own sensors if you wish. If you guys have the software installed, then you guys can do it with me. I've already have the code ready, but I'll explain line by line. So for those of you who have the software installed, you can sort of do it along with me. And for the others, you can do it whenever you get the time. Okay, so there are basically two aspects to this assignment. One is setting up the VREP environment, and the other is setting up the Python code. I will first give you instructions on how to set up the VREP environment right here. So this is how VREP looks for those who have not used it. And I think they've also given a new name. Yeah. So we will first import because it has many of the sensors already inbuilt, so you don't have to do much of the heavy lifting. Okay, so this is your Pioneer P3 DX robot. It's an example of a differential drive robot. A differential drive robot basically gives motor power to two wheels, and that's all it needs to be able to move around. Now, if you go here, zoom this in. Yeah, you will see that this robot is fitted with 16 different ultrasonic sensors. So if you recall from the lesson, your ultrasonic sensor is basically a proximity sensor. It can tell you how close obstacles are, but it's important to keep in mind that the range of these sensors are not infinite. It can only sense within like a meter or so. Let's click on 4. Let's zoom in here, and you can see that this is one of the 16 ultrasonic sensors, and this cuboid that you see here, right? It's basically the range of the sensor itself. Now, this is an important thing to keep in mind is the way they've programmed the ultrasonic sensor here is that it sort of behaves more like your infrared sensor. That is, it sort of detects in a line sort of way, but you can change that by using like a cone type right here, but I'm not going to do that. This is just for you to keep in mind. So a ray type is like your infrared sensor, and your cone type is like your typical ultrasonic sensor. And another thing to note is like the coordinate frames. So dealing with coordinate frames is like a huge issue in robotics. So Aditya mentioned this at the start of this lesson, that when he was doing like an assignment for like a 3D inverse kinematics script, right? He found it difficult to transform between one frame to another, and that is a huge problem that you should keep in mind. So you can see right here, like the global frame operates right here. This particular thing is the global frame. You can see that the z-axis points up, your x-axis points away from this, and your y-axis is along this plane. But for this particular sensor, your z-axis given by the blue line is along the x-axis of the global frame. So this is just something to keep in mind a little bit later. Yeah. Okay, so this is how the robot looks like. Now, if you recall from the previous session, there are two things that you need to do so that you can control this robot using Python. Okay, so the first thing is click on this right here. Click on resizable floor here and click on this script-like thing. So we need to first open up a communication channel between Python and VREP. And to do that, you basically need to add this piece of code right here. So what this does is this opens up a communication channel between Python and VREP on this specific port, 19,999. Now, for you can change this number to whatever you want, but it's better to use like the default settings always, because you don't know if some other number is used for some other port that we are unaware of. Okay. So now that we've added that, let's go ahead and increase the size of this map a little bit. Okay. Perfect. Okay, so now we have the robot right here, and we've also done one of the two things that we need to do to enable Python communication. The second thing is you need to go into Tools, Scripts, highlight the Pioneer robot, and click on Script Disabled. So what this essentially does is one thing. So any pre-defined robot in VREP, right? They all come in with a script itself. So for example, Pioneer P3X script, it basically runs its own obstacle avoidance. So somebody has already written their own obstacle avoidance algorithm. So if you were to just hit the simulation at this point without disabling that script, as I just did, the robot would end up moving. And you wouldn't want to do that because you want to run your own script. Okay. So those are the two things that you need to do. And once you do that, you can add an obstacle. Go to add, go to primitive shape, go to cuboid, and you basically have to choose like an appropriate size. Oops, sorry. And you have to disable this create pure shape object. So if you don't disable this, VREP cannot make this object detectable by the ultrasonic sensor. Okay, so now we've added a block. Now we just need to move it so that it is within the frame of within view of the ultrasonic sensor. So this is how you move it. You have to click on this symbol right here, and you can just drag it. Okay, so now we've added the robot, we've added the object as well, but we need to make sure that this object is detectable. Now, this is something that you just need to do in VREP. In real life, it'll obviously be detectable. So what you need to do is you need to click on this cuboid right here, go to common, and make it detectable, measurable, collidable. Okay. Okay, so that is all you need to do as far as setting up the environment is concerned. Any questions so far? Okay. And now let's move to the Python script. So I'm using an environment called Spider. It's spelled SPYDER. So it's a very handy tool to write Python scripts. It gives you like an environment for debugging. It allows you to see what variables are being saved and all that. Yeah. So this is the entire code. I'll explain it bit by bit so that you don't get confused. There are basically two portions of the code: this half and the second half. So this first half, it basically defines your variables that you need to use. And your second half is this part right here, which basically moves the robot until it gets close to the obstacle. So you first need to import a couple of libraries. This is how you import libraries in Python. So the sim library is your Coppelia sim. That is this VREP right here. If you import this, you can use all the functionalities of VREP in Python. Then you need to basically write some boilerplate code, which is like a standard code that you need to just copy and paste. So what these few lines do is it basically starts the communication channel. If you recall, we opened up a communication channel on 19,999, and this this code, at least what this does is it starts communication. It starts communicating between VREP and Python. So once you have that ready, what you need to do is you need to define object handles for your motors and your ultrasonic sensor. What I mean by object handles is that, so whenever you're programming, you need to have like variables, right? Even if you're adding two numbers, you need to store the result of that added number into a separate variable, right? So that's what we mean by handles. So for this is the command that you need to use to basically get your handles for your motors or for your sensors. It is simx get object handle. Now you have to call this command. You have to also invoke it from the sim library right here. Now to understand where this command comes from, you have to basically go to this website. So this is a list of all functions that you can run in Python that will control the VREP script. So I'll attach it along with this lessons PPT as well, but yeah. And yeah, this is the function to retrieve the object handle or the variable name of a motor or a sensor. So it's also important to note that you should create, you can basically go through these arguments yourself. You can basically copy this entire code and paste it right here. It's essentially what I did. And you can just change the names of these two names to your liking. So these two lines basically get the object handle for the motors. Now you can see that I've named them appropriately. Right here, where's the motor? Yeah, right motor and left motor. So it's important to have the same name right here as you have right here. Otherwise, it won't be able to pick up. And then you have to do the same thing for your ultrasonic sensor. So I am just using the fourth ultrasonic sensor, which is this one. So that it can, you can see it is in the view of the obstacle. And again, so once you've gotten all the object handles, what you need to do is, for the sensor in particular, you need to call the function, a particular function twice. One is to initialize the sensor so that it can start recording, and another time you have to call it so that you can actually get the data back. So simx read proximity sensor is the function that you're looking for. All right, so the first time you call it, it sort of initializes the sensor. But you need to call it again once you're actually running the robot. And you can see the documentation for that here. So whenever you're writing code for something, right, it's always important to So it basically reads the state of a proximity sensor. So you have to call it at least 2 times. One is to initialize it, and the other is to utilize it. Okay, so with that, we can at least start the simulation. Sorry, I'll explain this part also. You'll see it in action in a little bit. So what this essentially does is, once we've defined all the variables for the sensor and the two motors, we can now start moving the robot. So what this piece of code does is it moves the robot until it sees the obstacle within its line of sight, and then it stops when it's within 0.5 meters of the object. So to move a robot, as you've seen in the last lesson, you basically have to invoke this command, simx joint target velocity. And you have to do that for the left motor and for the right motor. And then, like I said, right, we need to call the sensor again. We just initialized it here, but we need to be able to read sensor data. And that is called right here again. We need to read it twice. And what I'm doing right here is I'm basically making the robot move until the sensor reads a value of less than 0.5 right here. And this, I'll tell you what this detected point is in a minute. So let's first run this portion of the code. Before that, just start your robotic simulator. Okay. Now you can, Spider is also cool that you can, in the sense that you can only run parts of the code. You don't have to run the whole thing. Okay. So now we saw that something's changed, right? So you can figure out everything else here. You just have to focus on 3 things. Detection state, detected point, and this surface normal. So right now it says that it's false. What that means is this ultrasonic sensor 4 cannot see anything, which is true because the cuboid lies outside its range. And because it cannot see anything, it thinks that all the objects are at a distance of 0 from it. That's just how it processes the data. So yeah, keep an eye on these 3 things. These 3 things will change once we start moving the robot. And to do that, okay, now I'll run the second portion of the code, which moves the robot until it comes close to the vicinity of the object. I'm moving it very slowly so that you can see what's happening. So these are some things that I just printed it out. So this is a very small number because it is essentially 0. So it basically says that the object is still out of reach. But now you can see that it's actually getting real values. Now this will continue until it reaches a value of 0.5, and then I've written a control command to basically make it stop. Okay, so that was basically it. You can see that the robot has stopped. And if you see here, right, you can see that all of these have changed. It has the detected state. The detected state is basically true. So it does see an object in its vicinity. And these are the values that it sees. So you can see that this is the value that you need to take into account when measuring the distance. So this is basically the distance between the sensor and the object, which is 0.5 meters. And yeah, that's basically it. That's the sort of assignment that I want you guys to replicate. So with this, you can now move the robot, and you sort of also give the robot eyes.